No, very good. Right, online. If you all look at the group chat, I sent you all a little PDF that we will use to work out some of the technical limits, right? Right, for those who did not start module 3 is limit, differentiation, integration. Very nice little module, right? Right, we will start with limit. The document I sent you all, ignore the integration, right? So it's after integration. Right, today our focus will be on limit. Limit 12, 9, and 8, right? Right. Limit, right? All right. Everybody ready now, right? All right. So I want to make sure that you all understand the concept of limits, right? So what you say? First thing, you need to understand the concept of a limit, right? The function I will use is one that we all familiar with, right? We are all familiar with a basic quadratic. This is the function y is equal to x squared. Let's just pick out a few values. 0, let's say 2. When x is 2, y is what? 4, right? Let's pick out one more value. Let's say 4, right? Value here is 6. All right. So we need to understand the concept of a limit, right? Should we sharp pay attention? We need to understand the concept of a limit. Somebody audio on? Kishan, we sit down, please. Right. So we need to understand the concept of a limit. So limits are written like this. Limit of a function. Our function are using here is x squared. As x approaches some value. So if I ask the notation for limit, it looks like this. The limit of f of x as x approaches e. What does that mean? Right? One simple way to look at that limit is like this. Let's pretend we have a tree. There's the ground there. There's a tree, and let us say there are fruit here. Let me say the fruit is liquor stick, right? And this is about 6 centimeters, right? So as we approach this fruit here, right? What height are we approaching? 6. And that's the concept or limit. So as we approach the fruit, the height we are approaching is 6 centimeters. Are you okay with that? So that's the concept of a limit. As you approach some value, you want to know what that function approaches. Are you okay with that? So a limit is the value a function approaches, right? As x approaches some particular value. So for example here, a nice simple example here. Limit as x approaches 2 of a function of this function here of x squared. Right? So let's approach 2. If we approach 2, if we approach this point here, if we approach this way, if we approach 2 from the right, let's say, the y value is how much? 4. If we approach 2 from this way, y value is also 4. So what that means is as we approach 2, regardless of the side, we get in a function, we get in a value of 4. All right. So if I ask you, what is the limit of x squared as x approaches 2? The answer is 4. But you'll recognize the only way I could validate this is if as the approach from the left and the right is the same thing. You recognize that? So the only way this limit here will exist is if as the approach 2 from the right and the approach 2 from the left, both of them giving you the same answer, which is 4. That's the only way a limit will exist, right? If you approach from the right and you approach from the left and you get the same value, limit exists. Are you okay with that? Right? So Shivish, what about if I approach 4? I want to approach x is 4. Look at the graph. Approach x is 4. What would be the limit? Approach x is 4 on the graph. It'll be 16. If I approach 4 from the right, I get in 16. If I approach 4 from the left, I am also getting 16. Same answer, limit exists. Huh? Right. And remember, when you're approaching, do approach here. Approach on the function. So approach on the function until you reach 4. And you get in 16. Approach on the function. When you reach 4, check your value. Okay with that? So this is very important, right? This symbol here means to the right. This symbol means from the left. That's okay? So if you approach from the right, you use a plus sign. If you approach from the left, it's a minus sign. Everybody okay with that? Yeah? So let's take a look at a different scenario, right? I want to make sure you understand the concept of a limit. The only way a limit could exist, Adrian, is if when you approach from the right and the left, they give you the same answer. All right? Suppose I gave you a function like this. You see that online? I want to specify something here, right? I want to make sure you see it. This is a hollow circle, right? That's a solid circle. What does hollow mean again? Right. So if I say x is more than or equal to 1, I would do a solid circle. Means 1 included, right? If I were to say x is more than 1, I'll use a hollow circle, which means that the 1 is not included. Okay? So let's take a look at this function here. This is 0, right? This function f of x. Let's see what's the limit as x approaches 0 of f of x. Right? To officially have a limit, we have to check it from the right, Sarah. And we have to check it from the left. That's the only way a limit could truly exist. That's okay? So Sarah, if you approach 0 from the right, means you're starting on the right and you're going towards 0. If you do that, what's the value? What do you think? You're approaching from the right and you reach it close to 0. This is x is 0 here. You're approaching what? 2. You're approaching y is 2. Correct? Azaria, if you approach from the left, and again, you're approaching 1. This 1 does not exist. You are approaching 1. Okay? So the answer here is 1. Okay? Hollow or solid, it don't matter. When you approach from the left, you are approaching the y value of 1. Everybody okay with that? Online, you all follow the concepts there of limits. Yeah? So what you will say, let me see who probably not paying attention. Eden, what you would say, since these two values are not the same, what you would say about the limit? You sure? What you will say about the limit here? It doesn't exist. Very good. I like how you're paying attention. It doesn't exist. Very good. You're okay with that? Yeah? Right? Before we go to the hands, I want to show you one more concept, right? Yeah. Right? Some of the attention span almost up there. About 2 minutes again. Right? Should be 2 minutes again. 2 minutes again. Should be 2 minutes. Right. So I showed you what's a limit, and I showed you how to prove a limit exists. One more thing I have to show you. I have to show you if a point or at a point, if it's continuous or not. So you want to know if something continuous or discontinuous. So watch this here. This is continuous. Correct? This is discontinuous. That's okay? Sometimes they will ask you, is the function continuous at a point? Or is a function discontinuous at a point? We have to be able to prove that. All right? How do we prove that, Shabish? Right? I have a minute again, Shabish. For your attention. Span expire. All right? 1 minute. So how do we show something continuous? Right? We have 3 rules to follow. Here's the first rule. Rule number 1, limit must exist. So for example, suppose I wanted to use this one down here, and I want to know if it continuous at 0. Is it continuous at 0? Kirish? No, because the limit doesn't exist. So because this first statement doesn't hold, ignore that one time. Discontinuous. So if this good, then move on to step number 2. F of A must exist. So the point must exist. So F of A must exist. So for example, if we were using 2, then F of 2 must equal to some value key. Must. Okay? All of this is not a note, sir. This is the handout I'll give you. Right? Well, this here, I just using a couple of examples. Make sure you understand, right? Right. So the first thing, the limit must exist. Second thing, F of A must exist as well. And third thing, anybody not paying attention in their class? Pay attention. Anybody? 2 of them must exist. 2 of them must be equal. So the limit as x approaches, the limit as x approaches A must be equal to F of A. Both of them must be equal. Okay? So let's check out right here. Right? Let's check out right here, Shavish. Last thing, Shavish, I'm almost done. Right? I know I went over my time. Shavish, let's check out this here. Let's check out at x equal to 2. Is this function continuous? Right? So let's start with number 1. Does the limit exist at x equal to 2? Yes. When x approaches 2, the limit is 4. So part 1, the answer is 4. Okay with that? Right. What is, so the limit as x approaches 2 of x squared is 2. Shavish, what is f of 2? Huh? F of 2 is what? When I plug 2 in here, is what? It's 4. Is it solid or hollow? I'll just pointing out something. So it's solid, right? Yeah? So f of 2 is 4. Are they equal? The limit as x approaches 2 of x squared is equal to f of 2. Therefore, continuous. A solid one is included. the hollow not included. Yes, yes. Pay attention now. What about here? What about here? Let's check out at x equal to, well, 0. Is it continuous? Is it continuous? Doesn't even make sense continuous, right? It's not continuous. Why, Adrian? Why is it discontinuous? Yeah. Why is this discontinuous at x equals to 0? Because right there, right here, so it doesn't, is discontinuous because the limit doesn't exist, right? First rule, limit must exist. Does the limit exist when x is 0? No, doesn't exist. Okay, so therefore discontinuous. Are you okay with that? Online, any questions? So we jump into the handout now. I need to join that. I'm sending handout, right? Because I didn't give you enough time to print it. Any questions online? Brittany, pay attention. You good there? Talia? Kevin, do you get my SBA? The people who have SBAs will probably need them this week here. All right, so nice. So let's go to the handout and let's see if we could run through the concepts here of limit something, right? You all can feel free to write up in it or you have to write. All right, so watch here. I use the same function. I try to use a function that we all know, right? We all know what f of x, right? So this here is the function f of x. Are you okay with that? Now, we need to understand this first part here. For a function y is equal to f of x, as x approaches some number a, the function f of x approaches some limit n. Are you okay with that, right? For example, in the graph above, as x approaches 2, f of x is 4. Right? I show you that already, right? It's the same function we're doing all the time. Okay, John? You okay with that? Yeah? Brianna? Okay there, right? Next, if you approach 2 from the left, you'll also get plus 4. Notice I use the right symbol. Negative sign above the 2 represents from the left. Right? If you approach from the right, notice typo should be a plus, right? Right? Those typos, they just keep it sharp. Otherwise, you fall asleep one thing in class. Right? So that plus sign means from the right. Okay with that? That plus sign means from the right. And since they are the same, right? Since they are the same, the limit exists. Limit of f of the pull-up. Another picture of the same question, huh? So now the one with the error. Right. For a limit to exist, both of them must be equal, right? Or you don't have an error here, right? They should be equal. I'll fix it and send it back. Actually, no, this PDF. That was the problem. That's why I didn't send something. Anyway, let's make a note of that now, please. Add that rule there, right? For a limit to exist, as the approach on the left and the right, it must be equal. All right, nice. We have some quick little questions. Sorry. Right. Right. So there is a function there that I really need to draw. Not sure if I ever showed you how to do this, but it's called a piecewise function, right? The function is split up into 3 parts. Right? Just do me a favor. All of this here is the same function. All of this here belongs to the same function. When the function is less than 0, the answer is 0. When the function is equal to 0, the answer is 1. When the function is more than 0, it's x squared. So we have to draw something called a piecewise function, right? So it will look at the top. Here is x is 0, right? That's the most important part, right? When it's less than 0, function is 0. When it's equal to 0, function is 1. And when it's more than 0, it's x squared. How do I draw that part? Right. And I'm drawing it from what is here. I'm drawing it hollow here and then all the way up here. Why did I put hollow there? Because 0 not included when it's x squared, right? So what you have in front of you there is a piecewise function. All right? Draw it, please, because we're going to use it in our example now. Write it down and draw it. Just follow what I did. When it's less than 0, it's always 0. So I draw a line on the on the x-axis. When it's equal to 0, it's a singular point. So I drew a solid circle at the point 1. And then when it's more than 0, I drew the x squared function. But notice there's no x squared on this side, only on the right side. And one thing I made sure and highlighted was that x is not 0 is not included there. All right, draw that for us, and then let's do some questions on it. Oh yes, draw that and then let it apply to the thing. So you will recognize that there are some functions that you consider, right? X squared and x squared. Ready? So we should finish. Draw that. Let's try that in. So tell me what you all think. For this function, does the limit exist at x equals to 0? Try that first. Those who online message your answer yes or no, right? Okay, fine. This is not number I have favor. Right, online, what you all got? Yes or no? Ramzo, I get one so far. Shivish, what do you think? Aaron, you well. You will not try to help them there. Yes, Shivish. Oh. Yes or no? Yes, why? As you approach from the right, the answer is what? What's the limit? As you approach from the right, follow the graph. Yeah, Shivish, sorry, yeah? Yeah. And as you approach from the right, right, as you approach from the right, you are approaching 0. As you approach from the left, you're also approaching 0. Nothing to do with the 1. Sorry? Therefore, what? The limit exists. Okay? Therefore, the limit exists. So the answer is yes. Right? I want to get 2 answers online. For you listening online? Brittany, you listen? Bob? So as you approach from the right and the left, you get the same value. Okay? Right. Here's the hard part now. Here's the hard part now. Does the limit exist at x equals to 0? So use back the rules I gave you. If you didn't write it down, still on the board, you can go back on the camera. So my question is it continuous? Oh, sorry. What I said? Sorry. My question is it continuous? Go back to the rules and I'll ask you. Right? Go back to your rules. Did the first rule hold here? Did the first rule hold in continuous? Does the limit exist? Yeah, we just prove it. So you have 2 more rules to check. 2 more rules to check. What's the graph? do you think, Nikolai? Now, why? They're not equal, right? Right. Very good, Amanda. Right, so the first rule in continuous is does the limit exist? The limit exists. So the first rule, okay, right? When x approaches 0, the answer is 0. Second rule is what? F of 0. Look at your graph. When x is 0, should be. You sure? Say that again, say that again. When x is 0, the function is 1, right? Are they equal? Right? They are not equal. Right? They are not equal, right? They are not equal, therefore, discontinuous. All right, let's do one more like this. That's not this is what ask a question there. So the x squared section of the graph not supposed to start at 1 on the y-axis. No, it wouldn't start at 1 because question said when x is more than 0. Right? So when x is more than 0, you have to start right here. Okay. So you're not starting graph there. Because remember, this is the x squared graph, right? That is the x squared graph. So if you say more than 0, they just want this part of the graph alone. Right? You can't start a graph here or start a graph here or anything. It's the same x squared function you're using. All right? Have you cleared up? Right? Let's try a hard one. Huh? Let's see if we can determine it continuous. Oh, by the way, for those who didn't get to write it down, just screenshot that if you want to write it down. Those are the rules for continuity. Write it down, or take a screenshot, or just open up your worksheet, right? Right, so let's make a note of the rules, and then we are going to attempt. Anybody write this? We are going to attempt to draw that. Right? I'll give you a minute, write it up, and then we go to the past paper conclusion of it. No, you take it out for sure. Yeah, when I get one, I sweat up for sure. Yeah, when I sweat up for sure. You stay up or it's coming out every day? It's coming every day. Ready? All right, so here's what you're doing tomorrow, right? I know it's a little challenging, but we should remember how to sketch graphs. Right? Remember what is x squared and remember what is x. Let's see if we can sketch this graph and then determine if it's continuous or not. As I said, it is a little challenging, right? Right? We are only interested between -1 and 2. Let's see if we can sketch this graph. Hopefully you know what x squared is, and then -1 is a shift way. Do you think? That is way again? Actually, before this here, I'm not helping you. I'm doing the first part for you. When x is less than -1, the answer is 0. Hollow circle there at the end, right? Hollow on the end here. Right? Nice. Can't say I didn't help you. Let's see a sketch. X squared minus 1 now. Right? So let's see how it went. Right. What does x squared look like? Let's remind you. X squared looks like this. X squared minus 1 of it will drop to 1. Correct? Remember that? Minus 1 means up, means it's going down 1, right? Good. How are we drawing this now? If you look at the graph, we don't want some parts of it, right? The graph has to go from -1 to 2. So we know its general shape, right? So let's just plug in -1 in there. But what you will get? -1 squared is 1, 1 minus 1 is 0. So your graph going like this. When x is 1, comes back up again, that's 0. When x is 2, 2 squared minus 1 is 4 minus 1 is 3. So we're coming up here to 3. Notice I have a hollow circle again. Everybody okay with that? You okay with that? Kill it? No? So what you say? Kill it. This is x squared. Yeah? That's x squared. So x squared minus 1 is down there. Okay? But do you want the whole function? No. You want how it behaves between -1 and 2. So you have to plug in the boundaries. Plug in -1 and you will get here. Plug in 2 and you will get here. Right? And leave out this and leave out that. That's okay? So it's like you're sketching it by cutting off where you're cutting off based on your arm domain. Okay? What is it called again? Restricted domain. Something like that. Right? Cut it off. Right? And the last one is a what? 5 minus x is a what, Nikolai? Like, what are you doing? On the keep it on here. Tequila, sorry. Yeah. 5 minus x is a what? A curve, a straight line, right? With a negative gradient, right? So which way will it go? Down or up? It'll go down. Right, have a little question, look. It's defined here. It's defined here when x is 2, right? So when x is 2, plug in 2 here, 5 minus 2 is 3. So therefore, what do I do with this hollow circle here? I'll have to pull it up and then go down. So that there is your piecewise function for this f of x. And yes, you have to learn to draw, right? You have to go back to the transformations I gave you. I gave you some standard graphs. You have to learn them, right? Because they could ask you something like this and ask you to do the exact same thing. Plot it, right? You'll follow why some parts hollow. Vikash, you follow why some parts hollow. Wait, Vikash on that. Vikash, you follow y at -1 it hollow? Yes. And at -2, y is solid? At, sorry, +2, y is solid? Yeah? Okay. Now, check and see, please. Is it continuous here? Is it continuous at -1? Is it continuous at 2? Hurry up. Do that fast. Do that fast. Online, please message it. This is a challenging topic, so I want to make sure you'll understand what's going on, right? Kevin, you there still? Kyra, you're following there? Kayla, Scarlett? Finish the first one? You finish the first one? Very good. Which one continuous? Both of them? And you got here. The second one, see what you flip again. Right, man. Let's see answers online. Let's see what you get. Kalia. See how you doing it? Right. Let's check out the first one. So when x is minus 1, first thing first. Step 1, let's see the limit exists. Right? Let's see the limit exists. So the limit as x approaches minus 1, sorry. Well, let's be careful when you're writing this up. Minus 1 from the left. When you approach minus 1 from the left, right, you're still getting 0. When you approach minus 1 from the right, you're also getting 0. Limit exists? Yep. The limit as x approaches minus 1 of f of x is 0. Everybody okay with that? Everybody okay with that? Listen there. Right? So that's step 1. Step 2 now. Step 2. F of minus 1. Does f of minus 1 exist? See what? What do you think? Look at minus 1. Hollow circle, solid circle. Hollow, right? So f of minus 1 doesn't exist. You okay with that? It doesn't exist. So therefore we conclude it's continuous. Everybody okay with that? Well, yeah, without the graph, can you identify that it doesn't exist at minus 1? Yeah. Without the graph. You're seeing that? Minus 1 is not defined there. So we don't need the graph all the time. Some methods you have to have the graph, some you don't. Yeah? Yeah. What the question you're asking there? Well, all right. Yeah. Technically, it doesn't fall correct. So yeah, you don't have to. F of minus 1 doesn't exist. Right? Let's go again. What about f of, oh, sure. Check out 2, please. F of 2. X is 2. Check it out. Check it out quick. Oh, yeah. Let's walk through this one. Right, let's walk through this one here. Who needs some help from? Anybody online can help me out here, boys? Ranju. Ranju, the people calling Ranju. Ranju, you might help me now, Ranju. Let's start with Ranju. Ranju, does the limit exist? Your mic now working. That's okay. Message. Your mic never working. Right. What is f? What is the limit of f of x if x approaches 2? Ranju? Either you or Sarah or Asia. Right, the answer is 3. Correct, Asia? Yeah? But as they approach from the right and as they approach from the left, it's the same y value. Right? So yes, it's 3. What about f of 2? What is f of 2, Adrian? What you got? Remember, you just when x is 2, go up and read off and see what the y value. 3. Is it solid? Is it solid? Yes. So it's 3. Very good. Okay? Sarah, continuous or not? Huh? Continuous? Yes. Continuous. Very good. Because the limit that x approaches 2 is equal to f of 2, therefore continuous. Nice job. Let's go again. Good job, Ranju. Yeah, Divish next, don't worry. Where Ariana now? Ariana? Ariana here, Tabisha here. You okay with that? Let's go again. When you okay with that? So sometimes to get the graph difficult. So we're going to look at some other options. All right? Any questions online? Right? Next class we'll do these rules, right? This one easy. Simplifying and thing, right? Right, I have to go all the way down here. This is limit by differentiation by first principles and thing. Somebody thinks the differentiation. Anyway, I'll go over everything, but I'll ask tomorrow. I have no choice. What is one here? Oh wait, no, I can't show you this one. Hold on. Hold on. Wait a minute. What is one here? This one we had to work in reverse. Copy it down. This is 2020 number 5. 2020 something. This is 2020 something. Any all-nighter? This is oh yeah, I will share it out. I'm just waiting on bio unit 1 and 2 on nobody. Yeah, but have a little clash. Yeah. We have a little clash with them. Well, with my subjects. But we'll look back for it, try it back. Right. So what's the key word here? Keyword. You can pick one word, one continuous. Question said it is continuous. Azaria. In the handout, that is best of it. I don't move it there because go back to the next to the last one. Hurry up. Caitlin, you have it? Yeah. All right, Caitlin now. Huh? All right. Time up. I just like drop them out. Yeah, like 5 marches. Leaving that also. All right, so the value of A, because it's continuous, right? This is equal, right? So if it's continuous, what do we know? Huh? The limit and the real close set. Right, so the limit exists, number 1, and what else? And when the value is, when the function is 3, they both equal, right? Remember that? Nice. So therefore, this is what we know. We know that the limit as x approaches 3 of f of x is equal to the limit as, sorry. Well, actually, we can say that too, right? I want to do it both ways. So we know that the limit exists. So as the approach from the right and the approach from the left, they equal. Correct? Yeah? So notice there's no graph here. There's no graph here. So how do you know which says two functions, one here and one here? How do you know which one will be used when you're approaching from the left? And how do you know which one to use when you're approaching from the right? Why? Very good. When it's less than, let's pretend here it's 3, less than everything here. All these values here, right? So when you're approaching from the left, you always have using less than function. When you're approaching from the right, you always use the more than function. You can answer that, please. Right? When you approach from the left, use less than function. When you approach from the left, use the less than function, right? When you approach from the right, use the more than part, right? Right? So if we're using, as you approach from the right, we're using this function. So that'll be a, don't write x squared, just write 3. That's okay? And if you're approaching from the left, use this function. That'll be a by 3 plus. Everybody okay with that? Right? All you have to do is just plug in the 3. Same thing you would have done if we had a graph. Remember when we had the endpoints that plugged in the value? Right? Sure. So all you have to do to get it, just plug in this value for x. Plug in this value for x. Those are the endpoints. So you'll get 9a is equal to 3a plus 2. Carry across 3a, and you'll get 9a minus 3a is 2. So you'll get 6a is 2, a is 1, 2. That's it. A is 1, 2. That's all we have to do. All this asks for a. Any questions? Any questions online there? Right, so once it tells you it's continuous, you have to use one of the rules, either the limit or the defined values that you see. Let's go again. All right, what's this here? Next one. Oh, yeah, I don't know what it is. try this one. Okay, guys, same thing. Same one. There's booklet here, there's no booklet now. That's it. Hold on there. Let's try this one here now. I know it's not the best pick in the world, but let's try that here. Find the value of b if it's continuous. That year is 2024. June 2024. Finish? Ignore the French underneath. Yeah? Oh yeah, try it quick. Again, what's the key word here again? Continuous. Should read that as one minute there, no more. When you're next one, it's funny. Oh, yeah. Any answers to B as yet online? You can message. If we get B. If we get B. Oh, yeah, answers are coming in here already. Nice, nice. That's what I like to see. Answers just rolling in. All right. What answer you got? Azaria, you got 3. So Azaria, what's the rule you use? You limit us, right? From the right is equal to. Nice. So as you approach 2 from the right, which function are you using again? One on top or below? On top. Nice. So that'll be 2 squared plus 1 is equal to b by minus 1. Nice. 4 and 1 is 5. 5 minus 1 is 6. So yeah. B is 3. That's okay? B is 3. That makes sense? You all could use that, or you could also use the limit as x approaches to of f of x is equal to f of 2. You could have also done that. F of 2, plug in 2 in here. So that'll be 2 squared plus 1. And the limit, all you have to do for the limit is just plug in 2 in the next one. Right, find this easy. Everything in the limit is easy, all the others easy too. Alright? So you could have also used that and you would have gotten b by 2 minus 1 and the same principle. Alright? Same principle. Alright? Yep, before we do our next one, I just want to show you something here. You don't understand, Shivish? Squared plus 1, I use the function. How what? How I get 2 squared? Sorry? What are the functions? Right? So when x equals to 2, which function is that? One on top, right? It's something different. Like something. Look, the back of the function. Huh? You don't understand the concept of the limit. Just they just have to. Yeah. Right, they plug in the value there, 2 squared plus 1. Just show them which function we use now. Right, I'll show you lesson. All right, what you say earlier. So just like how you have theorems for logs and theorems for summation and deviation, right? You have limit theorems, deviation, right? So here we have some rules that we can use for a limit. All right, so the first rule is that if we have a k, hold on, I'm gonna share it back. I couldn't write on this screen. All right, look at it. Working out. Right, here's the rule, right? Right? These are some rules that we could use, right? Should we pay attention, please? Right? So, for example, if you have the limit of x approaches, let's say 2 of 5 f of x, you don't have to multiply the 5 by f of x. You can take the 5 and bring it in front. So you will get 5 by the limit of x approaches to f of x. So you'll end up with 5 of whatever this is. Right? That's what they say. You can pull the k on the outside, basically. That's okay? If you have a product on the other hand, right, what you could do is you could write them separately. So the product could be written like this. Limit as x approaches a of f of x multiplied by the limit as x approaches a of g of x. So you can split it up. Right? If you have a plus sign in the middle, same thing, you can split it up. If you have a division sign, same thing, limit on top, limit underneath. That's okay? Right? And this one is very important because in one of the past papers, they gave you something like this. The square root of 2x. And people started to panic. How to do that? But it's quite simple. You could take this square root and put it outside. Right? So this rule is important. Right? You can put the root on the outside, or you can put the power on the outside. That's okay? If the power is a half, just work out this like normal and put it to the power of a half. That's okay? So how do we apply this now? Well, in order for us to apply it, we have two rules that we can use, and the third is to check, right? You have two rules to use. You can factorize, you can divide by the highest power, or you can check it with L'Hopital. You cannot use L'Hopital for your solution. Just to check your answer. All right? Huh? L'Hopital, I'll show you. I'll show you how to do it. It's using differentiation. All right? So let's start here. We have a nice example here. How do we work out the limit of this? Well, the first thing you would normally do should be just plug in 2 here, plug in 2 here, plug in 2 here. So you'll end up with 4. Sorry, it's minus. Sorry about that. You'll end up with 4 minus 4 over minus 2 plus 2, which is 0 over 0, which is undefined. That's okay? If it's undefined, we have a problem. We need a value. So when it's undefined, we have to come back here and use technique 1 or technique 2. I will show you how to do this later on, right? Probably not today. I'll show you next. Right. Here's what we're going to do now. We are going to try to simplify this. Right? One of the rules that they said that we could use is something called factorization. So let's factorize here. You'll end up with x by x plus 2 on this here x plus 2. What will happen? Cancel off. So you'll end up with x alone. Well, realize that? So you'll end up with the limit as x approaches minus 2 of x. All you have to do now is plug in your minus 2. Yeah, that's the next option here. So if factorization does not work, you divide by the highest power. Everything. So watch this one here. Watch this one here. Actually, let me do this one before. I want to make sure you all see it. Right, if you look on the board, you will see the limit as x approaches infinity of 3x over x squared minus 4. Right, look on the board. So you want to solve something like this. If you plug in infinity here and here, you'll get infinity over infinity undefined. But we need an answer. Right? Right? We need an answer. Are you okay with that? So therefore, we have to try different techniques. So let's see if we can factorize. X squared minus 4 looking factorizable. And they'll cancel off. No help. Right? So factorization didn't work. So now let's try something else. Let's try to divide by the highest power of x. The highest power of x is 2. So I'm going to divide everything by x squared. I'm going to divide all these terms by x squared. The objective is to simplify to get an answer. All right? What would happen here? This will cancel. So you'll get 3 over x. X squared on x squared as 1. 4 on x squared will be, well, 4 on x squared. That's okay? Follow what I did? You sure? So follow what I did? You sure? Next step, let's substitute x is infinity. So I'm going to put 3 over infinity, 1 minus 4 over infinity. Anything divided by infinity is what? Anything divided by infinity is 0. So you get 0 over 1, which is 0. So the limit of this is 0. Okay with that? Yeah? So that's the way you simplify limits. I'm not showing you the L'Hopital today, I'll show you next week. Alright? So basically, right? We have two options when we simplify this. Well, what are the two options, Shibish? And then what? So you factorize, right? So you factorize or you divide by the highest power. You okay with that? Try factorization first. If it doesn't work, then try division by the highest power. All right. So the objective is to move from undefined to some value, right? So once again, undefined, you have to use method 1, factorization, or method 2, divided by the highest power. All right. Any questions online? Online? Any questions?